Okay, so I was asked to go over this worksheet, so I figured I would do a video and post it so everybody could see it. This is the worksheet I handed out on Monday. Just going over the leading terms, coefficients, degrees, constants, and whatnot. So the first thing let's do the leading term. Now remember, the leading term, it has to be written in descending order to determine if it's leading, right? Biggest exponent to smallest exponent. So really your biggest exponent term is going to be the leading term. So like for number 1, that's going to be the 5x squared, right? Let me write that over the whole thing. 5x squared is going to be the leading term. But say if I look at number 2, for example, it's not in descending order because this right here should be in the front because it has the largest exponent. So if I were to write it in descending order, that would be my leading term. The leading term for number 3 would be this one, again, because that has the biggest exponent. Number 4 is already written in descending order. Number 5, the one with the biggest exponent, is the 21a to the 3rd. Number 6, it would be 4m to the 4th. So again, you're just looking for the one that has the largest exponent. That's the one that would be in the front and written in descending order. Number 8 would be the 13k to the 9th. Number 9, it would be the 12a to the 5th. 10, 17p to the 3rd. 11 would be negative 7a to the 5th. 12 would be 90n to the 9th. 13 would be just the y to the 6th. 14 would be 4x to the 2nd. 15 would be 9b to the 6th, again, the largest exponent. 16 would be 16h to the 4th. 17 would be the negative 16 into the 3rd. Okay, we'll skip 18, coming back to it. 19 would be 4a to the 2nd. Excuse me, and 20 would be p to the 2nd. Okay, so let's talk about number 18. We didn't really visit one of those that had 2 variables in it. But hopefully it'll be obvious that the largest exponent is 7. So don't let the x squared, y squared confuse you. So the leading term would be 6x to the 7th. All right, so that's all of the leading terms, the ones that have the largest exponents. If I were to rewrite them in descending order, it is the one that would be in the front. Okay, so the next thing I need to do is I'm going to do a circle around the leading coefficient. Okay, so it just follows what we just did. So like on number 1, it's written in descending order. The leading coefficient is the number that is in the leading term. So for all of the ones I already have a triangle around, it's just the number in front of that. So the negative 20, the 9, the 4, the 21, the 4. So again, it's just the coefficient, the actual number that's in the front of the leading term. Negative 7, 90. I'm going to come back to 13, 4, negative 9, 16, 16, negative 6, negative 4. So if you look at 13 and 20, both of those terms, the y to the 6th and the p to the 2nd, have no number in front. But really, we know there's a 1 right here, right? We know if there's not a number in front of a variable, it's really a 1. So the leading coefficient of both 13 and 20 are the 1s, or negative 1 in 13's case, in front of that variable. Okay, so that's the leading term, has the biggest exponent, and the leading coefficient is the number that is in front of the leading term. Okay, the constant is just the number, right? The number that has no variable on it. So here, oh wait, it says a rhombus, sorry. So the constant here would be negative 11. That's beautiful. So 2 doesn't have a constant. All of those have variables. Same thing on 3. Number 4, negative 12 is the constant. 5 doesn't have one. 6 doesn't have one. 7, 8, 9, 10, 11, 12 don't have one. 14 has one. It's 9. It looks like the only other one that has one would be 20, which is actually negative 20. So only the terms that are only a number, there's no variable attached, those are constants. So the only ones with constants here are 1, 4, 14, and 20. And then the last thing you're asked to do is to draw a square around the degree. And this is getting real messy. So the degree of the polynomial is the highest exponent. So like, since 5x to the second I know is my leading term, its exponent is 2, so that means it's a degree 2. Here it's the 6, the 4, the 2. I know it's hard to have already written all the way over these, and so on. So the degree of the polynomial is the exponent that's on the leading term. Now we did do a chart that had the special names of those on them. And if you look at some of these, like for example, number 1, since it's a second degree, right, we called that a quadratic. You're not asked to do that on this paper, so if you didn't, it's totally fine. But like some of them, like number 2, it's a 6th degree. We didn't go over that name. You're not going to be expected to know that name. Number 5, that one would be a cubic, right, because the degree is 3. So those are those. Where did I leave off? So 6, 4, 3, 7, 2, and 2. The only other thing that they don't go over here is you do need to know like how many terms there are. I didn't really talk about that on the sheet. So like, just as an aside, like this one, number 1 has 3 terms because there's 1, 2, 3 things that are being separated with plus and minus signs. Number 4, as messy as that one is, has 2 terms. Let's see if I can read any more here. So like, it looks like all of these, except for 11. 11 has 4 terms, but all of these have either 2 or 3 terms, which again is the most common. And remember, those also have names. Like 3 terms is called a trinomial, and 2 terms is called a binomial. Anything more than that, like number 4 or number 11, which has 4 terms, is just a polynomial. So just a little refresher on making sure we understand the terms: leading term, leading coefficient, degree, and constant. I hope that helps.